Imagine waking up to the news that astronomers have discovered a habitable planet just a stone's throw away in cosmic terms. A world teeming with life, oceans, and breathable air, orbiting a star we can see with the naked eye. This isn't science fiction anymore. Today we're exploring the question on All Sci-Fi What If we discovered a habitable exoplanet within 10 light years. The implications of such a discovery would be staggering, touching every aspect of human civilization. From revolutionary advances in space travel to profound philosophical questions about our place in the universe, this single discovery could reshape the course of human history. So let's embark on this journey of exploration and imagination as we consider the challenges, opportunities, and mind-bending possibilities that await us in our cosmic backyard. For centuries, humanity has gazed at the stars, wondering if we're alone in the universe. The concept of worlds beyond our star system has tantalized philosophers, scientists, and dreamers alike. But it wasn't until the late 20th century that we developed the technology to detect these distant planets. The search for exoplanets began in earnest in the 1990s with the first confirmed discovery in 1992. A pair of planets orbiting a pulsar. This was followed by the detection of 51 Pegasus b in 1995, the first exoplanet found orbiting a main sequence star. Since then, our ability to detect and categorize exoplanets has grown exponentially. Space-based observatories like Kepler and TESS have revealed thousands of worlds beyond our solar system, ranging from gas giants larger than Jupiter to rocky planets smaller than Earth. One of the key concepts in the search for life-supporting worlds is the habitable zone, the region around a star where conditions might be right for liquid water to exist on the planet's surface. The Goldilocks zone varies depending on the star's size and temperature. However, being in the habitable zone doesn't guarantee habitability. Venus and Mars, for instance, orbit within our sun's habitable zone, yet neither currently supports life as we know it. Now, let's zoom in on our local stellar neighborhood. Within 10 light years of Earth, we have several intriguing star systems. 1. Alpha Centauri, 4.37 light years, a triple star system including Proxima Centauri, our nearest stellar neighbor. 2. Barnard Star, 5.96 light years, a red dwarf with at least one known planet. 3. Wolf 359, 7.86 light years, another red dwarf featured prominently in Star Trek. 4. Sirius, 8.6 light years, the brightest star in our night sky is actually a binary star. 5. Luyten 7268, 8.73 light years, a binary system of red dwarfs. With the discovery of Proxima Centauri b in 2016 sparked excitement as it was the closest known exoplanet to Earth. However, its habitability remains uncertain due to intense stellar flares and probable tidal locking. For our scenario, let's imagine a new world, which we'll call Nova Terra, orbiting a K-type orange dwarf star 9 light years away. This places it just beyond our current nearest neighbors, in a region of space we've studied, but where we haven't yet detected planets. Nova Terra is slightly larger than Earth, with 1.2 Earth masses and 1.1 Earth's radius. This gives it a surface gravity about 1.1 times that of Earth. Noticeable, but not overwhelming for potential human visitors. Initial spectroscopic analysis reveals an atmosphere rich in oxygen and water vapor, with tantalizing signs of vegetation. Let's break down the key features that make Nova Terra so exciting. 1. Atmosphere, similar to Earth's, with a nitrogen-oxygen mix that humans could breathe. 2. Water spectral analysis indicates vast oceans covering about 65% of the surface. 3. Magnetic field. A strong magnetosphere protects the planet from its star's radiation. 4. Plate tectonics. Evidence of geological activity crucial for long-term habitability. 5. Rotation, a 26-hour day, close enough to Earth to avoid major circadian disruptions. 6. Axial tilt, about 22 degrees, providing seasonal variations similar to Earth. The star itself is a K-type orange dwarf, smaller and cooler than our Sun, but larger and hotter than red dwarfs like Proxima Centauri. This stellar class is considered promising for habitability, as they're stable over long periods and emit less harmful radiation than many other star types. Proximity of Nova Terra presents an unprecedented opportunity for interstellar exploration. At 9 light-years, it's tantalizingly close, yet still impossibly far with our current technology. Conventional rockets are out of the question. Even our fastest spacecraft would take tens of thousands of years to reach Nova Terra. We need to think bigger. Let's explore some potential propulsion methods. Nuclear pulse propulsion. Theorized in Project Orion, this method uses a series of nuclear explosions to propel a spacecraft. It could potentially achieve 10% of light speed, reducing travel time to Nova Terra to about 90 years. Pros. Based on understood physics, potentially achievable with near-future technology. Enormous radiation risk. Potential for weaponizing limited by treaties. Laser sail technology, proposed by the Breakthrough Starshot Initiative. This involves using powerful lasers to accelerate lightweight sailcraft to incredible speeds. It might push tiny probes to 20% light speed, reaching Nova Terra in 45 years. Pros. No onboard fuel required. Potential for very high speeds. Cons. Enormous infrastructure needed for laser array, limited payload size. Fusion drives. While still theoretical, fusion propulsion could offer a balance of high speed and sustainable payload capacity. Some designs suggest speeds up to 15% of light speed might be possible. Pros. High efficiency, potential for both speed and cargo capacity. Cons. Require major breakthroughs in fusion technology. Antimatter engines. The holy grail of propulsion, antimatter engines could theoretically approach 50% light speed. This would make the journey to Nova Terra just 18 years from travelers' perspective thanks to time dilation. Pros. Unparalleled energy density. Potential for relativistic speeds. Cons. Antimatter production and storage pose enormous challenges. Generation ships. Rather than trying to reach incredible speeds, we could send slower ships designed to support multiple generations of travelers. Pros. Based on more achievable technology, allows for a larger population. Cons. Social and psychological challenges of multi-generational space travel. Each of these methods present its own set of engineering challenges, from material science to life support systems capable of functioning for decades or centuries in deep space. The discovery of life on Nova Terra would be the greatest scientific breakthrough in human history. But it also presents unprecedented ethical challenges. We'd need to establish strict non-interference protocols to protect any native ecosystems. The Prime Directive from Star Trek might serve as a starting point, but real-world application would be far more complex. Key considerations include remote observation. Our first priority would be deploying a network of telescopes and probes to study Nova Terra from afar, gathering data on its biosphere, geology, and potential civilizations. Contamination prevention. Any mission to Nova Terra would need rigorous protocols to prevent Earth's microbes from contaminating the alien biosphere. Communication attempts. If we detect signs of intelligent life, how do we make contact? Options might include radio signals, laser communications, or even physical artifacts sent via probe. But should we announce our presence at all? Ethical frameworks. We'd need to develop new ethical guidelines for interacting with alien life. How do we respect the rights of non-human intelligences? What if their moral systems are radically different from our own? Global cooperation. First contact is too important to be left to any single nation. We'd need unprecedented international cooperation to manage our approach to Nova Terra. Even if Nova Terra is habitable, it won't be a perfect Earth analog. Its gravity, Day length, atmospheric composition, and native microorganisms would all pose challenges for human colonists. We have two main approaches to dealing with these differences. Terraforming. This involves gradually altering Nova Terra to make it more Earth-like. Potential methods include introducing Earth plants to boost oxygen levels, altering the planet's orbit or rotation, constructing massive climate control systems, using engineered microorganisms to alter the atmosphere. Pros: could make the entire planet habitable for humans. Cons: ethical concerns about altering alien ecosystems could take centuries or millennia to complete. Human adaptation. Instead of changing the planet, we change ourselves. Genetic engineering to create colonists better suited to Nova Terra's conditions. Advanced life support systems and enclosed habitats. Cybernetic enhancements to help humans thrive in the alien environment. Pros: faster to implement, preserves nature ecosystems. Cons: limits habitable area, potential for creating a divide between adapted and non-adapted humans. The discovery of Nova Terra would reshape human society on Earth in profound ways. Unifying effect. A habitable world within reach could provide a powerful common goal for humanity, potentially easing international tensions. Technological acceleration. We'd see massive investments in space technology, propulsion research, and exobiology. Existential risk mitigation. The promise of a backup planet might spur efforts to address climate change and other essential risks on Earth. Economic shifts. Industries related to space exploration and colonization would boom. We might see the rise of exoplanet futures markets. Philosophical and religious impacts. The discovery of alien life would change many belief systems and force us to reconsider our place in the universe. Potential for conflict. Nations or corporations might race to claim Nova Terra's resources, potentially leading to a new era of colonial expansion and exploitation. Looking beyond initial exploration and colonization, what might the future hold for humanity's relationship with Nova Terra? Two-world civilization. Over centuries, we might develop a true two-planet civilization with regular travel and communication between Earth and Nova Terra. Divergent evolution. Over millennia, humans on Nova Terra might evolve naturally or through engineering to better suit their new home, potentially becoming a new species. Gateway to the stars. Nova Terra could serve as a stepping stone for future exploration, using its resources to launch missions deeper into space. Technological symbiosis. The challenges of colonizing Nova Terra might spur the development of technologies that also help us solve problems on Earth, from climate control to food production. Cultural exchange. If Nova Terra harbors intelligent life, we might see the development of the first truly alien human hybrid culture. Ethical challenges. As our capability to alter Nova Terra grows, we'll face ongoing ethical dilemmas about the extent to which we should reshape the planet versus preserving its native state. Discovery of a habitable world within 10 light years would mark the dawn of a new era for humanity. It would challenge our technology, our ethics, and our very conception of our place in the universe. As we gaze at the star harboring Nova Terra, visible in our night sky, we'd be forced to confront profound questions. Are we alone? Should we go? And if we do, what will we become in the process? The journey to Nova Terra would be the greatest adventure in human history. But perhaps the most important discoveries would be the ones we make about ourselves along the way. In striving to reach and understand this new world, we might finally learn to truly appreciate and protect our own. What do you think? How would you approach colonizing an alien world? And what challenges do you foresee that we haven't discussed? Leave your thoughts in the comments below. If you like this video, don't forget to like, subscribe, and hit that notification bell for more mind-bending, all sci-fi what-if episodes. Until then, keep looking up and keep imagining the possibilities.